Okay, now we're going to look at a vector placed in standard position. Now remember, a vector is anything that has a magnitude and a direction. We place the vector in standard position from the origin. In this case, let's look at a 25 Newton vector that is 21 degrees north of west. That would be quadrant 2. Let's remind ourselves in quadrant 2, we will have a negative x and a positive y. Let's write our vector 25 newtons and an angle of 21 degrees. We want to resolve this vector into its x and y coordinates. We'll record an x here and a y here. To do this, we remember SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. To get our y coordinate, we will use sine equals opposite over hypotenuse. In this case, the sine of 21 is equal to y over 25. And y will equal 9.0 newtons. Let's write that next to the y. 9.0 newtons. Now we want to find our x coordinate. We will say the cosine of 21 is equal to x over 25. X equals 23 newtons. Let's record that next to our x. Now what we need to do is look at our signs. Again, quadrant 1 is the plus plus quadrant. Quadrant 2 is the minus plus. Quadrant 3 is the minus minus. And quadrant 4 is the plus minus. We then realize our x value should be negative. So we record a negative next to it right now. What if we know the x and y components of a vector, and we want to find the resultant vector, which is the hypotenuse of the triangle. We want to find our angle theta here. Remember, a vector has both a magnitude and it has a direction associated with it. Let's say our x value is 5.0 newtons and our y value is 3.0 newtons. Looking at this quadrant, we're in the minus minus quadrant here. So we have a negative for our x and a negative for our y. This would then be our south of west quadrant. We need to use the Pythagorean Theorem in order to find the resultant vector r. R is equal to the square root of 3.0 squared plus 5.0 squared. Notice how I do not use negatives because squaring a negative number makes it become a positive. The resultant vector in this case is going to be equal to 5.8 newtons. Well, that's only 2 of the 4 items that a vector has. This is the magnitude with a unit associated with that. Now we're going to use tangent equals opposite over adjacent in order to find the angle. So I say the tangent of angle theta is equal to 3 divided by 5. Notice how I'm not using negatives again. We want the angle, and we will reference our negatives according to the direction. Theta is equal to 31 degrees. Remember, you need to inverse tangent in order to find this. What we're saying is, what angle is the ratio 3 over 5 for y to x true? What angle makes that ratio possible? So you will inverse tangent, and it will give you 31 degrees. Now, since we are a -5 for the x and a -3 for the y, we are in the southwest quadrant, and you can clearly see where the vector is drawn. So we will now add the south of west notation after that. And you can see there are 4 items then for this vector: a magnitude with a unit, an angle with a label for that angle.